Boundaries are everywhere. And in practice, you're gonna have to handle several requirements with boundary conditions. For example, if you're building a game, you will have a requirement that is like, if the score is between 100 and 200, the player should get 50 bonus points. Or if the total ordering is above 100, shipping costs are $5. So these kind of requirements are very common. And as software testers, we need to make sure that our software behaves correctly whenever inputs are near the boundary. The off-by-one mistakes, as we call them, are very, very common in real life. And one systematic way to think about boundaries and make sure that our software works is to perform what we call boundary analysis. And the idea of the boundary analysis is to look to the boundary and see what happens when our input is near this boundary. For example, if we have a condition that is x greater than or equals to 100, the 100 represents some sort of boundary that we have in our program. And making sure that our system behaves correctly when inputs are around this number makes totally sense. Let's do it together with some new terminology. What happens to our system if the input is in the on point? The on point is the number that is exactly on the boundary. In this case, the on point is 100. So what happens to our system if x is 100? Does it behave correctly? Then we can also think about the off point, which is the opposite of the on point. The on point is the closest number to the on point that flips the condition of the on point. What do I mean by that? So the 100 is the on point. 100 is greater than or equal to 100. So 100 makes this condition to be true. The off point is the nearest point to 100 that flips the condition, meaning makes the condition false. So in this case, 99 is the first number, the one that is closer to 100, that makes the condition to be evaluated to false, because 99 is not greater than or equals to 100. So what happens to our system when the input is on point and off point? And following this idea, we can think about in points, and in points make our condition always true, and the out points, which make our condition always false. So these are the four terms that we usually use when doing boundary analysis. And the interesting thing is that in this example, if you notice, the off point is also an out point, and the on point is also an in point. But this doesn't have to be necessarily true for all the cases. For example, if we change this condition to x greater than 100, then the on point is still 100. But now the on point is an out point. And the off point, which is the closest number to the on point that flips the condition, in this case, we need the nearest point that makes the condition true, which is 101. So what we do when it comes to boundary analysis is to think about these 4 points. Again, the on point is the exactly point on the boundary. In points make the condition true, and there might be many of them. The out points make the condition false, and the off point is the one that flips the outcome for the on point and is as close to the boundary as possible. And your task as a software tester is to make sure that your system behaves correctly in these 4 cases. Okay, but how can we think of on and off points if we have multiple boundaries? I'm now going to discuss the approach proposed in the A Simplified Domain Strategy paper. And the suggestion that this paper makes is that we should handle every boundary in an independent way. And for each boundary that we have, we should pick the on and the off point. And by pick, I mean testing the on and the off point for that boundary. And while testing one boundary, we use varying in points for the remaining boundaries. To really see it happening, we can use what they call a domain matrix. So let me go to a concrete example. Let's suppose we have the following condition: x greater than 0, and x is smaller than or equals to 10, and y greater than 1.0. So we have basically 3 boundaries there. We should look to each one of them in an independent way, meaning kinda ignoring the others, and think about the on points and the off points, and simply use any in points for the other conditions. So for example, for the first boundary condition, x is greater than 0, its on point is 0, and its off point is 1. So this means we're going to have one test, T1, where x is 0, and for y we just pick any in point. For example, I picked 10 for test 1. Then test 2 has the off point 1, and another typical in point for y, let's say 16. And then these are the two boundary tests we do for the first condition. So then we go to the second boundary, which is x is smaller than or equals to 10. The on point for that condition is 10. The off point is 11. For y, we pick any in point. I chose 109.3, 2390.2, so completely random in points. And finally, for the y, the on point is 1, the off point is 0.9, and now any in point, but now for the x variable. And that's it. These are the 6 tests we should do in order to exercise the boundaries of the big condition under test. Please notice that you did not try all possible combinations. After all, that could be impossible to do in very large problems. We just tested a few of them, and that is why we call this approach a simplified one. We will talk about combinatorial testing later on. To sum up, in this video we discussed possible ways to do boundary analysis. Besides the specific technologies we discussed here, like on and off points and the domain strategy, the main message I want you to have is that boundaries are very dangerous areas for bugs, and therefore we should explore as much as possible those boundaries and make sure that our software works as expected.